A pleasant day to you, ma'am. I am Bitonio Sanchay A from BS Ed Major in Science with the offering number of G338. The topic that I'm going to discuss today is all about the factors affecting the rate of chemical reactions. But before we begin the discussion, let me ask you a question first. How does the knowledge of chemical reactions help us in our daily lives? Chemical reactions has a huge help in our daily lives. By observing chemical reactions, we are able to understand and explain how the natural world works. Chemical reactions turn food into fuel for your body, made fireworks explode, cause food to change when it is cooked, make soap remove grime, and much more. The learning outcomes for this discussion or lesson is to define reaction rate, identify the factors affecting reaction rate, and use of experimental data of how each factors affects the rates of reaction. What is rate of reaction? The rate of reaction is the rate at which chemical reaction proceeds. In simpler terms, in this illustration, the rate of reaction is how fast or how slow a chemical reaction occurs. But how does a chemical reaction occur? Chemical reaction occur when two or more molecules collide with each other and must possess enough activation energy with the minimum amount of energy needed to start a reaction. Chemical reactions in general proceeds at different rates. The difference in rates of reaction is caused by several factors such as the concentration of reactant, temperature, particle size, and the catalyst. The first factor of chemical reaction is the concentration of reactant. If the concentration of a dissolved reactant is increased, the reactant particles become more crowded. Therefore, there is a greater chance of the particles colliding. Thus, the rate of reaction increases. We can now conclude that the relationships between concentration of reactant and rate of reaction is directly proportional. Since the higher the concentration, the faster the rate of reaction, and the lower the concentration, the lower the rate of reaction. Next is the temperature. Once a substance is heated, the particles move more quickly and they have more kinetic energy. The particles collide more often and more of the collisions are successful. The rate of reaction therefore increases. Same with concentration, temperature is also directly proportional to the rate of reaction. As temperature increases, the rate of reaction also increases and vice versa. Next is the particle size. Smaller reactant particles provide a greater surface area which increases the chance for particle collisions. So the reaction rate increases. Therefore, larger particles have small surface area, while small particles have greater surface area. If the surface area of a reactant is increased by cutting the substance into small pieces by grinding it into a powder, more particles are exposed to the other reactants, increasing the rate of reaction. Last factor of chemical reaction is the catalyst. Catalyst, for instance, is enzymes. Enzymes lower the activation energy of a chemical reaction and increases the rate of reaction without being consumed in the process. Catalyst works by, first, increasing the frequency of collisions between reactants, second, altering the orientation of reactants, third, reducing intramolecular bonding within reactant molecules. Fourth is the donating electron density to the reactants. Therefore, we can say that the lower the activation energy, the faster the rate of reaction. The higher the activation energy, the slower the rate of reaction. So before I end my discussion, let me share it to you our video experimentation during our senior high task.
In this experiment, we will show you how surface area affect the rate of chemical reaction. So here we have two clear glasses, 2 tablets of vitamin C, which is pulverized, while the other one is a whole tablet. So this is the comparison of the surface area, and we need to put first a water into the 2 clear glasses. And now, we will see the rate of the reaction. So, as we can see, the reaction of the vitamin C tablets, the pulverized one is immediately reacted and was already dissolved. Unlike to the whole one tablet is still being dissolved. In this experiment, we will show you if how temperature affect the rate of chemical reaction. So here we have a 2 clear glasses, which is a cold water and hot water, and a 2 effervescent vitamin C tablet. Now, as we can see if how the cold water and the hot water reacted with the vitamin C tablets. The cold water is still reacting, while the hot water is almost finished. So the higher temperature, the faster the rate of reaction.
So that was just a short video experimentation during our senior high school year. I hope you learned something today. Thank you and God bless.